All right, so let's move on then into the word problems again. So we're going to start with just regular, straightforward sentences, something along the lines of, what is 20% of 38? All right? There are two ways that you can go about doing this problem, and depending on who you're talking to, you may get different ways presented to you, okay? Me personally, I like to do the translation from English into math, because that's the kind of guy I am, all right? I like to look at this and say, what? How do I translate the word what? It's an X. Is translates to an equal sign. 20%, when you deal with the algebraic equations, you got to use the decimal form of all your percentages, which is why I ask you to do these things, so that you can convert 20% into 0.2 of, translates into multiplication, and 38 translates into 4. So it is literally a direct translation. This is what, each one of these is just you translating word for word, right? It's like, again, learning a separate language. That's how you learned a separate language. They started off by giving you vocabulary. Here I am giving you vocabulary, all right? Now your job, solve. How do you solve for x? You take 0.2 times 38. What do you get? So 7.6 is 20% of 38. Another technique that you may have seen or you may hear of is this technique. And if you go to the Learning Lab, most of the Learning Lab people do it this way because most of them are coming through the nursing division, and the nursing division does ratios all the time. I mean, that's what you do in nursing all the time. It's ratios, 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 constantly ratios with more ratios on top of your ratios. So when they do percentages, they say, no, there's no such thing as a percent, it's just a ratio. Whatever. Either way, there's nothing wrong with it, okay? It's perfectly okay to do this. The way this works is that you need to substitute in for the three pieces of your ratio. The 100, folks, always stays the same. That 100 is always there, all right? And the way you do this is by using the words and the symbols that are on here. Wherever you see the percent symbol, go inside of your sentence and grab the number that's next to the percent sign, put it in there, okay? So here's percentage, put in 20. And then you just have to figure out which of these two you have. Go to the word of. What follows the word of? 38. That's what you substitute in for the word of. What's next to the word is? What? That's what you're trying to find out. X. And then when you have a ratio, a fraction equals a fraction, what do? Cross, multiply, and solve, or multiply and divide, right? You could if you wanted to, but cross multiply. 100x equals 20 times 38, and then how do you get x by itself? Divide by the 100. Or, again, think of it as the multiplication of these two divided by that one, all right? And that tends to be what people have seen more often than not. And if you can simplify your problems into a one-sentence percentage problem, this is all good. This will always work, okay? Because if you do 20 times 38 divided by 100, guess what you get? Same difference, all right? Whichever way you've... Again, it's one of those where if you have seen it and done it this way and this is what you've been doing for years, I don't want to stop you from doing it, okay? All right? The reason why I like to do it this way is because when you get into the real world, you're not going to get a simple sentence of what is 10% of 50 or 6 is 8% of what, right? I mean, that's not what your word problems are going to be. Your word problems are going to be that a person who weighs 38 38 kilograms needs 20% of something in order to survive, right? And it's not just this sentence, okay? So I will tend to do it this way because this is the way it's easier for me, and I'd like to think that it's going to be easier when you get into bigger businessy type problems. I will try very hard to simplify problems like this if I can so that you can see it, okay? Oh yeah, true. It's not a bad way to check, certainly. It's always nice to have two methods so that you can do it one way, do it the other, and if they come out the same, probably a good bet you're right. Again, I don't want to stop you from doing a specific way, because if it works, I want you to get the right answer. That's more of what I'm looking for. But I want to make sure you get the right answer. And again, we'll get to it in a little bit, once it starts getting more complicated than this. So, anyways, let's try another one like that. 45 is 6% of what? So change the sentence a little bit slightly. And again, I will still do this problem both techniques. So 45 is 6% of what? Again, my translation technique. Again, just take the sentence and please don't screw up copying the number. %. How do you write that as a decimal? Please be careful with. Don't tell me it's 0.6. That would make me sad. Remember that of translates into multiplication. Again, this is one of those things. The reason why I want to do this is that so that when you guys start looking at the word of, you quit thinking of it as a preposition and start thinking of it as a time sign. Once you can quit thinking English and start thinking math, this class gets much better. And then, what do we translate what into? And so this is why we did our algebra stuff back in chapter 5, because how do you solve for x? How do you get x by itself? Divide, right? Because this is multiplication. You need to undo division, undo multiplication with division. Divide by 0.06. So x is whatever, 45 over 0.06. 750? 750. All right? Now, doing this is over of. There's nothing wrong with doing it this way, because this is a nice straightforward sentence. So again, is over of. You're trying to create. The 100 always starts there. Always. Okay? This is always, what's that next to the percent sign? 6. And it's just straight up the percent sign, right? That's the nice part about the is over of stuff, is you don't have to think about translating the percentage into a decimal. That's why some people like it more, okay? Technically, the divided by 100, guess what the 6 divided by 100 turns it into? 0.06, which is, I mean, essentially you're doing it, you don't see it, okay? Now, is goes on top, of goes on bottom. I always like to go to of first, folks, because of is a preposition, which means the object of it is always after it. So go to the word of. What follows the word of? What? So put where of is the letter x. And then what's next to the word is? 45. And again, if you've been working with these sorts of things, you will immediately say, well, you take the product of these two and you divide by that one. I would rather you think of this as cross multiply and solve. (6x equals 45 times 100), and then to get x by itself, and nicely enough, that's going to give you the same answer. All right? Okay, so, not bad. One more. We've had the is gone, we've had the of gone, now let's have the percent gone. 20 is what percent of 12? All right, so again, my technique, the translate technique, 20 equals what percent? It's just x, and then I'll put a little caveat in this, folks, is that you have to convert it into a percent after you're done. All right, when you use it down here, the x is going to come back as a decimal. It's your job to change it to percent. Of is multiplication, 12 is 12. So 20 equals x times 12. How do we solve for x? Divide by 12. What's 20 divided by 12? 1.666666666. 20 divided by 12? Don't do 12 divided by 20, do 20 divided by 12. So, remember that this is the decimal representation. I need the percentage. What's the percentage for this? So when you do that technique, please remember that your x comes back as a decimal. You need to make it a percent. When you do the is over of is 12. Remember that the of is on the bottom. The is the 20, and this time we don't know what the percent is, x. And again, the nice part about this is it's always going to be multiplying this diagonal, dividing by across from it, or 12x equals 100 times 20. Solving for x, we divide by 12. And when you do this one, you will get 166.666666666, and that will be the percentage, okay? So the is over of techniques, when you have to find the percent, it will actually send the percent back to you, because the 100 is always in there already.
So will 166 and 3/5 work for that or
No,
not?
because 3/5 is 166.6, not repeating, which is different, obviously. All right.
It doesn't matter if we reduce the like from that cost.
No, nope, nope, nope. Reduce all you wish if you have a fraction you look at and can immediately reduce. Please do it, in fact. All right, so those are nice, straightforward sentences. The real world, of course, comes in word problems, right? Oscar Mayer makes $2.2 million each year in sales. (45.2% of sales are from hot dogs. Guess what I'm going to ask? What is Oscar Mayer's sales in hot dogs? So this is more along the lines of the way questions normally show up instead of something along that line, right, where it's a nice one-sentence thing. Usually you're going to get 2 or 3 or 4 sentences of stuff, right? Part of your job is to look at the stuff and say some of these numbers are meaningless and some of them are not. That's part of what you got to do, all right? So what I would like to see you guys do, again, how you do this, if you can see what the answer is right off the bat without thinking about it and you can do it, great, okay? I'm going to write it out, all right? Oscar Mayer makes $2.2 million each year in sales, all right? So I'm going to say total sales equals $2.2 million. And I may even convert that to a number that doesn't have million sitting into it so that I have the number of zeros I want floating around. So I may even say this is $2,200,000. Again, you need to be able to convert this into this and do it correctly, okay? You guys are going to own a company that's going to make money in the millions. You got to be able to handle it, all right? All right, that's the first sentence, right? So I translated the first sentence. Move on to the second sentence, right? Don't try and jump to the answer right away. Write down what you know, okay? This will save you from running into a problem. 45.2% of sales are from hot dogs, okay? So 45.2%, how am I going to write that math like? 0.452, very good. How am I going to translate the word of? Times sales, okay? Now, if you want, you could substitute in what total sales are right away, but I don't even want to do that. I just want to grab the words and put it down there, right? There's nothing, this is total sales, right? R, how do I translate R? Equals, wait a second, shouldn't it be the word is? It is a form of the word is, it's the plural form. You do need to know a little English to do math, damn. And then from hot dogs, is from a special math word? No, right? It's kind of like the or a or an. You can pitch it whenever you feel like it. So this will be hot dog sales. So you have to be a little bit ingenuitive and see that from hot dogs means hot dog sales, okay? And of course, your reason we call it hot dog sales is, what's the last sentence? What are sales from hot dogs, right? So how do I figure out what my hot dog sales are? You substitute in total sales into this equation. Notice there were no X's floating around in here. There were no Y's floating around in here. I just used words. Isn't that much better, right? You don't have to have X and Y. Use X and Y when you have words like what, where you don't know what the variable is. Here, you actually know what the variables are, right? It's total sales and hot dog sales. So what's 0.452 times 2.2 million? So on an average year, Oscar Mayer is going to sell $395,000, almost $395,000 worth of hot dogs. 900? 994,000. So even closer to 300. 994,000? 400? Okay. I'm deaf, sorry. So almost $1 million come from hot dog sales. That's even better, right? We eat a lot of hot dogs. All right, so if you could look at this set of sentences and see that the question asked, what is 45.2% of 2.2 million? And you can do that problem really quick, great, okay? Realize, though, that there may have been lots more words floating around in this description, right? I could have started talking about Oscar Mayer as a company and that they have 2.33 million workers worldwide, and they've got 1.4 million management people worldwide, blah, 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 right? Throwing lots more numbers up at you. Again, some of them you're not going to use. That's definitely the way the real world works, right? You get way more information than you need. Hello? I mean, part of your job is to disseminate the information. All right, so let's try another one like that. Hmm? What? Oh. You would have said, well, the thing is, this would simplify to what is 45.2% of 2.2. So then you would say 45.2 over 100 equals x over 2.2 million. Yep, percent always goes over 100. All right, so who's the other one? Oscar Mayer and what's the one that's in Beloit? That's Hormel? Okay, so Hormel has sales of chili at $550,000 each year. Again, I'm just making these numbers up, folks. I have no idea if that's real. But it's probably not too far from the truth. That's my guess. If chili sales are 61% of total sales, what am I going to ask? What are total sales? Right, and I probably would have started this problem in the real world by saying, Hormel, a company that was started in a garage 53 years ago with 10 employees cooking chili on an open pit and canning it with, by their children and wives and blah, 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 blah. And told you the whole story of Hormel and how great it is and how wonderful of a small world company it is. And again, translate though. Hormel has sales of chili at $550,000. So you'd say chili sales are a little bit more than $500,000 a year. All right, here we go. Chili sales. R, you guys have now done your English requirement for the day. That's an equal sign. 61%. Translate it correctly. Please be careful with that. Of the special magic math word times, and then total sales. Call them total sales. Because, of course, what did the question ask for? What are total sales? So, chili sales substituted into the right spot. How do I get total sales by themselves? Divide by the 0.61. Please, 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 please be careful with that. When you divide 550,000 by 0.61, what do we get? What was that? So a little bit over $901,000 in total sales at Hormel. Again, this is money. Since the value that you're trying to calculate is money, I don't have to tell you where to round it. You always round money to the penny, folks, period. All right? Well, bankers, they have to round eventually to the penny once they get to dollars. If they're dealing with percentages, they don't round diddly squat, right? All right. Again, please realize that what we started with, the chili sales, was the of, not the is. All right? And this is when you divide as opposed to multiply. So the key here is realizing that the is over of is written as $550,000 is 61% of what? And that when you translate that into the is over of technique, it's x over, wrong way, 550,000 over x equals 61 over 100. Cross multiply and divide. Again, if you can read those three sentences and see that that's what it's saying and translate it into the straightforward is over of technique, great. Right? There's nothing wrong with it. Hopefully, if you happen to do this problem wrong, right? So imagine if you looked at this problem and said, oh, all I have to do is take 550,000 and multiply by 0.61. If you take $550,000 and multiply by 0.61, what do you get? You get like 300,000 some odd dollars, right? If you tell me that total sales are $300,000 and chili sales are $550,000, you live in La La Land, right? If you look at your answer, see if it makes sense. Don't just get the answer and then skip merrily along to the next question, okay? Think about it. This is reality. All of these questions are going to be based in reality. If you tell me that total sales are less than a percentage of sales, you have screwed up, okay? Money makes sense. Don't screw that part of it up, all right? But that requires, after you get the answer, and think for a second. Okay? It's just a matter of you guys not being lazy. Because I know you understand it. You can't tell me that if you told me total sales were 300,000 and chili sales were 500,000, you would laugh at yourself for saying that, right? But you actually have to stop and think about it. Okay. Sorry, I will now take off my preacher outfit and go back to being a teacher. But all right, so let's see. I have 40 marbles left. If 16 of my marbles are green, what percent of my marbles are not green? All right, so again, start the translation process. I have 40 marbles left. Or I have 40 marbles, right? All right, now here's where you have to be a little bit cautious and where English turns into a problem for us. English is an awful language, folks. It would have been really better if the Nazis had won and we all spoke German, because German is a great language. It's always very explicit. You know everything that was said as soon as you say it because it translates gorgeously. English, on the other hand, we can be really lazy and it's okay. Again, it is kind of the American way, so somehow maybe it's good, maybe it's bad. But now here we go. 16 of my marbles are green. How do we translate that? In theory, we say, 16, and how do we translate the word of? Normally you would say times my marbles, total marbles, equals green marbles, right? Does that look right? Why is that wrong? I translated it correctly, right? What do I have to do with that total marbles? Do I multiply by it? What do I really do? Subtract? I'm going to divide. Well, but how could of translate to divide, though? Right? Yeah, I got lazy, right? The way I should have said this is that 16 out of my marbles are green. And I just got lazy, okay? So that's, sometimes English sucks, folks, right? So scratch that part of it out, because really you shouldn't be multiplying, because there really should be 16 out of my marbles are green. Green represents... So what is that sentence really saying? All it really says is that my green marbles are 16. I have 16 green marbles. It was just telling me that 16 is a portion when it said out of, okay? So that one, and now I'm going to ask what percent of my marbles are green. How do you figure out a percent? How would I do it? Exactly. We would take 16 divided by 40, and that would be my percent as a decimal. You'd have to convert it into a decimal. Now, can we translate it into this is over of stuff? We kind of could, right? But how would we write that, right? This is tough, right? I mean, this is where it starts to get hard, okay? And I blatantly admit it. So there is a third technique that the book uses, pardon me while I go through it, right, is that this is my beer example. Portion equals base times rate. Or the portion equals the total times whatever your percentage is, right? The reason I like to use it is what are the three letters of portion, base, and rate? PBR. For those of you who are maybe a little bit older, you know what a PBR is. I know, it's making a comeback. This is weird. Well, of course, it's not going back to what it should be, which is $4.99 a case, right? Yeah. But anyway, so one of the things that you can utilize when you're dealing with percentages is to say, remember that the portion, 16, equals the base, or the total, times your rate. And in order to get your rate, you just divide by your base. It's another technique, and the book uses this one as well. So if you guys look at the book to find out how to potentially attack these problems, this is another technique you might see, okay? Again, lots of other ways to look at this sort of thing. So what's 16 divided by 40 again? Somebody give that to me. 0.4. 40% of my marbles are what? Are green. What did I ask for? Please don't tell me that this is 40%. Remember what I asked for. 40% are green. What percent is not green? Again, a lot of times on a test, I'm going to see 40% is the answer because you guys are so happy to get the answer that you skip merrily along to the next question. Please don't do that. Tell me that 60% are not green because, of course, the complement of 40% is 60%. Again, there's that term complement. We'll talk about that more in Chapter 7. All right, so now let's get to the problems that are a little bit more interesting. How is this problem different than any of the other problems we've been working with? Yes. What does a raise mean? It means a percentage increase. When you are dealing with percentage increases, folks, doing the is over of technique tends to fail. Okay? Unless you're really clever. All right? So before we dive into this problem, when you're dealing with a percentage increase, how does it work? I mean, what would you do to solve this problem? You would take 20% of 100,000, and then what would you do? Multiply it. And then add it back into the $100,000, right? So there's this adding portion to a percentage increase problem, okay? So the way percentage increases work is that you take your starting value and you add the percent of your starting value to get where you end up. Note that this percent times start, this is a multiplication. If you want to, you can put a little percent inside of the times sign in there. We are multiplying the percentage. You said it, but sometimes we tend to not write it down clearly enough. All right. This is always the way percentage increase works, okay? I am going to give you a note. And this note's going to be rather big. When you have a percentage increase problem, one of the things that you will never do is subtract. You always add. All right, you're going to see why that's important in a second, because this is the easy part of the problem. We're going to do the hard part next. All right? So, to figure out this problem, you're going to tell me here that my start equals $100,000 and that my percent equals 20%. And again, make sure you translate it, okay? Translate it into math because I want you to do this as a math problem. Take this information and plug it into your equation, okay? So everywhere you see the word start, put in $100,000, right? So we start at $100,000. And we're going to add our percentage, which is 0.2, times start again, $100,000. And this will get me where I end up. Okay, hopefully most of you could have done this problem in your head, and I'm making it long and sort of annoying because when we do the next problem, it's going to be very important. Okay? So here you're going to say, great, this is 100,000 plus 20,000 equals end. I am now making $120,000. Woohoo! All right, so the hardest part to dealing with percentage increase problems and decrease problems, really, is when you look at your number, figuring out whether it means the start or whether it means the end. Okay? I got a 25% raise, and now I make $100,000. How much was I making before my raise? All right, now, again, this is the sort of problem where you probably think you can do it in your head. What's the answer if you're going to do it in your head? $75,000, right? That's what the standard response is. That's what the gut response is, right? Because you're going to take 25% of 100,000 and you're going to subtract. Amen. 75,000 is wrong. Because 25%, what's 25% of 75,000? What's a quarter of 75,000? Is it 25,000? Not even close. That answer is wrong, okay? But it's really, really, really hard for us not to think that $75,000 is not the right answer, because we've been doing it for a long time, and I swear to God that there are some grade school teachers out there that teach you doing a percentage increase backwards is subtraction. I can't prove it because they don't videotape those classes like I do with mine, but you cannot subtract when you have a percentage increase problem. So when you see that this is a percentage increase problem, your formula is always this. There is no subtraction in it whatsoever. I got a 25% raise. My percent is 25%, which equals 0.25. You guys will be careful doing that again. And now I make $100,000. What is that $100,000 this time? It's where I ended up, right? Because I'm saying what was I making before that raise, that's where I started, right? The cool part about it is that we still do the same thing, right? We still do the same thing that we did over here. Everywhere where you see this variable being used, substitute in the number, same thing with the percent, right? So everywhere where you see percent, put in 0.25, but this time what's missing? The start. And here I substitute in the $100,000. Now here's where it gets a little bit tricky, right? This start, is there a number in front of it? No. What number is in front of there, though? 1, right? Remember that there is really a 1 in front of this. So if I have 1 start, and I add 0.25 starts to it, I have 1.25 starts. Okay? Think of start as x. This is the same as x plus 0.25x. You combine your x's, or you combine your starts to say that this is 1.25 start equals $100,000. How am I going to get start by itself? Divide. Not subtract, but divide. Where did I start at? $80,000. And when you're done, go back and make sure that makes sense, right? Same thing we did with $75,000, right? When we thought about it, we thought, what's 25% of $75,000? It's not $25,000, right? Here, what's 1/4 of $80,000? What's 1/4 of 8? 20,000. What's 80,000 plus 20,000? Yes, that gets me to the 100,000. Again, by stopping and looking at it and making sure that it checks back to the beginning, you can see whether or not you're right or wrong. All right? Of course not. I have nothing wrong with X. I like X. But I don't want, I use the word start to point out that it doesn't matter, right? This way you can tell that we're talking about where did I start. You don't even have to know that X represents blah. Right, again, this is me trying to make this less like algebra and more like life, right? Because you guys didn't seem to like the algebra stuff. All right, so I was making $100,000. Now I'm making $104,500. What am I going to ask? Yeah, What was my percent raise? So, again, you read this problem and realize that it's a percentage increase problem. What's the formula that you work with for percentage increase? It doesn't change. Start plus percent, start equals end. This time, though, I've given you the start and the end. Which one's the start and which one's the end? So the only tricky part here is remembering where you started and remembering where you ended. Again, think a little bit about these sorts of problems, right? If this is a percentage increase problem, you had better end at a higher value. If you don't end at a higher value, you got them in the wrong order. Again, just be careful, okay? And we do the same thing. Plug the numbers in. I need to solve for the percent symbol, or think of that as x, right? If you like it as x, that's cool. I mean, I like to leave it as the percent symbol, but then people start thinking, well, what percentage are you talking about? It's like, well, how do I get x by itself? What do I have to do first? Subtract the 100,000, right? Please note that you do not find your percentage change by just dividing the two numbers. That never works, okay, unless you're clever. I'll show you at a later date how to do that, but that very rarely works. All right? So we subtract $100,000 from both sides. Please note that you always have the subtraction on both sides of the equal sign. So x times $100,000 equals $4,500. How do I get the x by itself? Divide by the 100,000, right? Again, be careful with this. This is the decimal. You got to make that into a percent. All right? Be careful with that. Just remember that when you're doing the math, the number you get is always going to be the decimal. Whew. You have to convert it to get the percent. Please note that normally the way you get a percentage increase is that you always take the difference between where you started and you ended. Always. You have to subtract the numbers first and then divide by a specific number, okay? Now, I would like to do one more problem like this, just so that you can be careful with it, all right? My shoes cost $75. That's a 7, I swear. In 1995, those shoes cost $32. So I have been buying the same type of shoe for 20 some odd years. If you've known me back in 1995, you would have seen me in the exact same pair of shoes, folks. Same color, same make, always the same. Now, I change, manufacturers from time to time because, sometimes it's Perry's Docksider, sometimes it's the Timberlakes, sometimes it's, whatever. But same shoe. I'm a mathematician. They tend to be that way. What am I going to ask? Yep. And you will see shortly why I asked this particular question. She gets all the money anyways, folks. I have no money. I only get money when she gives it to me. Doesn't matter. I just, as soon as I get it, it's like, oh, so it's all yours, hon. Don't worry about it. She is on all of the bank accounts. I'm only on some of them. She was worried, and I'm like, look, I'm not. It's all yours. All right, so this is a percent increase. The formula is the same, okay? Please remember that you get a note card for the next test. Yes, you get a note card for the next test. It better flip and have this formula on it somewhere. As long as it's not bigger than a half a sheet of paper, I'm okay. All right, so the question then is, where did I start and where did I end on this problem? I started at 32. Where did I end? 75. Again, since it's a percentage increase, the number had better be increasing. Don't screw that part up. All right. Substitute the numbers in. 32 plus. Now, I'll leave it up to you guys. Do you want me to keep using the percent symbol, or would you like me to change it to an X? Percent times 32 equals 75. What am I going to do first to get the percent by itself? Subtract the 32. What am I going to do to get the percent by itself? Divide by 32. What'd you get? Give me all the digits. Okay, 1.34375. So is my percentage 1.34375%? No. This is in decimal. What do I got to do? Move it over 2. Please make sure you move it the right direction. When you're adding a percent sign, you move it 2 to the right. This is 134.375%. There is nothing wrong with getting more than 100%, right? Because what do you notice about this number? It more than doubled, right? That means the percentage has to be more than 100%. That tends to piss some people off because they think percentages always have to be between 0 and 100. Tough shit. You are going to get percentages that are more than 100. Guaranteed, okay? Welcome to the world of pricing, right? I mean, prices have doubled. That's the way it is, right? That means that they had more than a 100% increase. When you're decreasing numbers, yes, you can't decrease more than 100% unless you're paying people to take your product, which is weird, okay? But increases very regularly are more than 100%, right? In fact, if you look at most businesses' markups, almost all of them are more than 100%. Lots of them are in the thousands of percents. Some of them are in the tens of thousands of percents, all right? All right, so that one's just pointing that out. So that's percent increase. What am I going to do next? Exactly. All right, so I was making $60,000 a year. Governor Walker cut my salary by 6.9% so that I could pay for my retirement. Welcome to the state of Wisconsin. What am I going to ask? Why is exactly right. What's my new salary? Okay, so this is a percentage decrease problem. What do you never do when you have a percentage decrease problem? See, I didn't even have to write it down that time. If I did, folks, it would be in really big letters. Same way as before, okay? So when you're doing percentage decrease, don't add. And it's going to be tough because your gut wants you to. You want to do it like there's no tomorrow, okay? All right, so what's the formula for calculating percentage decrease? Instead of start plus, what do I do? Minus, right? The cool part about it is that the formula looks really similar because it is. The only difference is that instead of adding, you're subtracting. All right, so one of the things that you guys have to do when you're dealing with these problems is noticing when one is a decrease and one is an increase, okay? That's part of your job. So you need to look for words that say, you know, I got a pay cut, I got a pay raise, I got 20% less, I got 40% more, right? Those key indicate percentage increase versus percentage decrease, okay? My advice to you, get out your highlighter, and when you are reading the word problems in the homework, highlight the words that tell you whether it's a percentage increase or decrease, okay? All right, so We're going to do these the same way, though. That's the cool part about it for me, is that I've given you the formula. Now you just have to tell me which pieces of this do we have. The $60,000, is that the start or the end? I was making 60 grand. I want to now know what's my new salary, hence that's the end. So part of this is reading, verb tense. Right? Was, that's the past, right? That's before, that's where you started, right? The other way to think about it is that since this is a percentage decrease, am I going to get a number that's less or more? Less, therefore, since it's more, this has to be where you start. My cut was a 6.9%. Again, please convert that to a decimal properly. Don't give me a 690% pay cut. That would suck. And again, everywhere where you see these values, plug them into your formula, right? So $60,000 minus 0.069 times $60,000 equals my ending salary. So again, I'm hoping you could have done this one. Maybe not in your head, because multiplying 69 times 6 is a little tough. But what's 6.9% of 60? And then subtract my pay cut off of my salary. What's my new salary? My final salary is now $55,860. Welcome to being a teacher in Wisconsin. That doesn't even take into account the pay cut I got for having to pay for my health insurance as well. Right? Used to be they covered all of it. Now I have to pay 20% of it. Yeah, because then you know how the governor is screwing you instead of just guessing how the governor is screwing you. Luckily, I was prepared and greased myself up appropriately. All right. So, I have $100. This is 20% less than what I started with. How much did I start with? So prior to this class, if you were given this type of problem, what would have you said the answer was? First off, is my number bigger or smaller? Bigger. So what would have you done? You'd have taken 20% of 100 and added, wouldn't you? You just said, oh, you had 120 bucks before. You guys are now smarter than that, right? Yes, you are, damn it, Leanne. You now know when you see 20% less in your head, you immediately think, I am not going to add a thing, okay? I'm only going to subtract. So you might say, what's 20% of 100 and subtract that would, once you figured it out, you would be a little bit nervous. But this is a percentage decrease problem, again, because of the word less. I would love it. Love it if, as you were doing word problems on your homework or on a test, you wrote down which one it is by putting the formula underneath it, right? Writing this formula down on the problem, even if you do nothing afterwards, gives you 3 points guaranteed on that question. Okay? You didn't do jack diddly squat, but if you gave me the right formula, that's the first step. That's at least 30% of the problem. Not even more. I mean, depending on how nice I am, I may even give you 4 for writing this down. Okay? Now, The reason I would give you 4 is that hopefully this would be the first step you do, right? That gets you another point, folks, right? You converted 20% into 0.2, and I'd be like, yay! Now, the $100, is this where I started or is this where I ended? That's where I ended. Okay. This gets you 5 points if you stop right there, right? This is half of the battle. You haven't given me an answer. You haven't come anywhere close to the right answer yet, but you've given me all the information that's in the question, all right? Now it's just a matter of putting it in and solving, right? Start minus 0.2 equals $100. Exactly. 1 start minus 0.2 starts. That's 0.8 times my starting value is going to give me my 100. How do I get my starting value by itself? Divide by the 0.8. 0.8. 0.8. We have 1 start. We're taking away 0.2 starts. 1 minus 0.2? 0.8. $100 divided by 0.8? And now you can think about it. 20%, right? That's 1/5. What's 1/5 of $125? $25. What's 125 minus 25? That's 100. Okay? I was making $110,000 at Epic. Now I'm making, what was that number I was making before? The other problem? After my 6.9% pay cut? 55,000. What was my pay cut? To switch jobs. Oh yeah, Epic had better health insurance than this place does, which is kind of sad. What was my percent pay cut? Sorry. I could ask you what my pay cut was too, and what would you do if I just asked for what my pay cut was? Yeah, you just subtract the two of them. Cool. But since I asked for my percentage pay cut, now you look at this and say, now it's a percentage decrease problem. So the first thing that you will write after you highlight the percent pay cut is start minus percent start equals the end, because that's always the formula for a percentage decrease. Where did I start? Oh, to be back at Epic and working 60 hours a week. There's a reason I left, folks. Imagine, if you will, you're 40 and you're working with a bunch of 20-year-olds and you have to work 60 hours a week. When I was 20, being around 20-year-olds, 60 hours a week was no big deal, right? Because we were all that way. If you know what that way is. 55,860 is where I ended up. I really shouldn't do this problem. Again, substituting the numbers, all right? Again, note that I'm not just going to divide the two numbers and guess which number is correct. which is sometimes workable, but not. All right, so how do I solve for my percent, or how do I solve for this if this were x? Start the same way, right? You're going to subtract the 110,000 right off the bat. And you may get nervous right away. Oh, shit, that's a negative number. What's my number after I do 55,000? What is it? Negative? Negative 54,140. And you should be a little bit nervous because you're thinking negative numbers. Wait a second. I know there's no such thing as a negative percentage. That's really weird. But what do you do when you go back and look at the other side? What do you notice is still hanging around? And then you guys remember, if you take a negative and divide by a negative, what happens? Whew. You breathe your sigh of relief, right? Because this is really a negative percentage, 110,000. And in order to get the percent by itself, we need to divide by the 110,000, but also by the negative, so that negative goes away, which is nice. And let's suppose that I asked you to, just for simplicity's sake, round to nearest hundredth of a percent. That tends to be what most of the world does when they write percentages down, is they round it to a hundredth. Not uncommon, unless you're a bank. Banks never round. All right, so all right, so what is my percent? Give me all the digits, folks.
492181818.
All right, 4921818, or is it 8181? 181818. Okay. So I said to round this to the nearest hundredth of a percent. Do I round it right now?
No.
Why not? It's not a percent yet. This is still a decimal. Convert it to a percent first, then round it. Okay? So how do I convert this number into a percentage? Now round the number. Okay? So here you would say, oh, this is approximately 49.22% rounded to the nearest hundredth of a percent. All right? When you are rounding percentages on my tests, I will always tell you to round it to the nearest hundredth of a percent. In the homework, they will ask you to round to different percentage decimal points, tenths, hundredths, maybe even thousandths. Make sure you follow the directions.
I'm confused why you subtract, because what the algebra, it says minus, but then you subtract it anyway. I don't get why you do that.
Why you would subtract?
Yeah, because when you do algebra, you do the opposite.
What's in front of this 2?
Nothing.
A plus sign, right?
Yeah.
What's the opposite of a plus sign?
Negative.
That's why we subtract, right? Well, think of it like this, right? What if I rewrote it? If I were to rewrite this, I would rewrite it as negative percent 110,000 plus 110,000, right? What's the symbol in front of the 110,000? Hence subtract. So it's just that I happen, the order is rewritten here so that the number is first. There's always a plus symbol in front of this, unless this number happens to be negative, in which case then it's not. One thing to note, folks, when you did those percentage increases or percentage decreases, note what the formula was for both of them. Take the difference between the two numbers and divide by where you started. You always do that. The algebra actually tells you that that's what you always do. And you always just make sure that the number is positive, right? So if you're ever trying to figure out a percentage increase or decrease, subtract the two numbers, divide by where you started. All right? Yes, Nick? No, you got until next week.
Oh, we're not doing.
Yeah, well,
So we're not